So today we're going to talk about building Zero-CVE container images at scale. My name is Dale Rodriguez. I'm a happiness engineer and also a senior solutions engineer at Chainguard. So let me tell you a little bit more about me. I'm a certified Vuln hustler. That means that we hustle vulnerabilities at Chainguard. 10 years focused on product management, security, and also solutions engineering. And another 7 years focusing on cloud native security. You can find me on LinkedIn at the URL at the bottom if you're feeling lucky. And let's go to the next slide. So what is Chainguard? Why are we here? First and foremost, Chainguard's goal is to be the secure source for open source. We believe in the open source community. We support the open source community, but we wanted to enhance the open source community by securing containers, libraries, and also virtual machines within the OSS community so that you can run this cool stuff in production environments and your compliance and security people won't bang you upside the head. So we have over 1,818 images, 134,000 plus versions, a whole lot of images, and you all can see the build number. I don't even feel like saying it. And of course, no one buys the factory. We sell images and a couple of other things. These are all of the tools that we use to build software at Chainguard. Melange is our package manager that helps us to build APKO packages. Octo STS is a GitHub security tool for security tokens. SigStore is for signing. We have a whole bunch of Terraform providers. And last but not least, Malcontent will check your container images for malware. So there is no magic to Zero-CVEs. There's a lot of automation, debugging, a whole bunch of cloud compute costs, test and joy, and a lot of questioning your own sanity because this shit is very hard. So first of all, before we talk about the factory, I'm going to talk a little bit about the philosophy of building from source. And also, if you've ever heard of open source malware, right? So when you build from source, first of all, it allows you to trust the source, right? So you want to provide depth in your defense. And what I mean by that, if you look at the little small diagram over there to the right, you'll see that if you have a very low visibility, limited visibility into your awareness blinds you from risk. What we do at Chainguard is we want to expand that visibility and build all the way down to the file system itself. So depth will mitigate uncertainty, and most importantly, when you have this depth, you'll be able to trust the stuff that you build. Also, we're building software with more safer compiler options. When you look at a lot of upstream projects, a lot of the languages aren't compiled using safe compilers. So we do our best to recompile all packages and binaries with safer options so we can reduce vulnerabilities in the stack. So what is the Chainguard's factory? At a high level, we're going to download the OSS project. We have some cool automation in the background that's going to generate a package build, then generate another CVE remediation if necessary. That stuff is going to go into a package repository. Those two blue boxes at the bottom represents building that image and testing it, and then we're going to push that out to an image repo. The top boxes that you see there, the package and image boxes, those are just some examples of how we do it. So let's dive in a little further. The assembly line. So essentially, the Chainguard factory assembly line runs right through the middle of the factory. Everything touches the assembly line, and we have to keep it moving. We're building a lot of stuff daily. So all 1,818 of those projects are rebuilt on a daily basis. That's to cover for zero-day CVEs and also to maintain updates in line with projects from an automated fashion. So most importantly, we have a lot of GitHub PRs, and I'm going to dive into those in a second. Also, our package building system is running on Kubernetes, and then also in that background, we're executing our package build tool called Melange. So as I mentioned, we really have tons of PRs. This is just a screenshot of some version request updates. As you can see, we have in this particular screenshot, we got about 65,000 K closed, 407 open. When these are generated, there's a new upstream release. We have some automation that matches the version differences. We have GitHub commit specs. And so essentially what we're doing is making sure it's the right image. Then we're going to we're going to do build and test results on each of those. And we're going to do that twice because we want to make sure that the image is proper, functional, and most importantly, performant. This is a sense of scale. So in this particular slide, we rebuild every package from source. So in this graph, these are the numbers of CPUs that we spin up as we're building these images. So this is our all-world builder. One of the challenges about this is when you're spinning up this many Kubernetes nodes, you can really have a lot of degradation on performance with our packaging system, so we had to kind of bring this in-house to make this a little bit better. So essentially we spent up about 1,000 CPUs to process this, and then we spin them back down once the build process is complete. So we want to automate all the things. We want to monitor upstream projects and ingest new releases. That's why we're releasing daily. Most importantly, we're going to monitor multiple version streams of upstream projects. So we don't just provide latest. We provide every single tag that's supported by the project. And the reason why we do that is everybody doesn't use latest. You should not pin the latest. God bless you if you do. And most importantly, pinning the multiple stream versions allows us to maintain an EOL upstream for up to 6 months. So in the event that a project goes into life, we can support that project for a year after 6 months. And most importantly, we're going to monitor the CVEs and we're going to scan for those CVEs. And at Chainguard, we resolve CVEs. Criticals are 7 days. High, medium, and lows are resolved within 14. And the robots do most of the work. I don't do it. So can't have a talk at AWS reInvent without AI. So we use AI to diagnose and fix our build errors. It improves our tests. It has made my life very, very easy with submitting PRs, and it processes a lot of good stuff for us. But the biggest thing is that our AIs are generating a lot of telemetry from our build, scan, test, and our test logs. So this information allows us to improve our factory, making sure that we're making the right decisions when we're building our software. So this is an example of AI kind of doing its thing. The main thing I want to point out, though, is that when this AI PR is generated, it is also assigned to an engineering group. So a human does verify the work before it's submitted. We don't trust AI yet. We do not want to become Skynet. So essentially, we're going to make sure that the errors in the build logs are highlighted. We're going to do some suggested fixes as well. And then we're going to also triage and remediate that. That at the moment is done by a human. So testing. Testing is also important. Our images do not get tagged until they pass tests. Just because we download and rebuild a package and package it up into an image doesn't mean that that's complete. We want to make sure that it's fully functional. And so a lot of times what that means is spinning up an actual Kubernetes cluster, running a real world test of that particular project to make sure that it's functional. We do a little bit more than just hello world when we're testing these projects. So this is kind of an example of where when the image comes into the PR system or the factory, it's going to spin up that test harness. It's going to be deployed. Those probes will provide the functional testing. We'll leverage Helm, Docker, or whatever tool we use to deploy for that particular test. Once that runs and that's certified, then that image is released. So the factory is the scale and how we build a functional, scalable factory. So our images are always signed with SigStore and pushed to our customers' private repos. When you become a customer at Chainguard, you get your own pretty repository with your domain and your images. We release those typically within an hour. You can clone your images from our repository to yours. And most importantly, we have LDAP and other features that allow you to customize those images so you can have your own code and image program leveraging Chainguard images. That way we build those for you so you don't have to manage that in-house. And as you can see in the green, That's essentially an example of your name here with a particular image type. And then on the tag history, you can even try and travel essentially and look up previous builds if you like. So we also have free images. I have about 54 of those. Those images are latest only. We have some base images, Python, JRE, Ruby, Node, and PHP. And then we also have some application images that you can use for free. Postgres, MariaDB, MongoDB, Redis, and Valkey. So we got about 54 of those and counting. All of these free images always have Zero-CVEs. They have SBOMs. It's essentially a free version of our enterprise product. And you're welcome to use it. We'd love to see what you build. And also enterprises, commercials, or whomever you are not one size fits all. So we built custom assembly. Custom assembly allows you to customize the golden images that we built and then make them your own. So you can add your own packages, create your own entry points. And what this does is this allows you to make our workflows fit within yours. The idea of building these images is not for you to change how you do things, but it's more so to add a complement to the way that you're currently doing business. So you can add packages, you can do all updates, and also they all sign with SigStore. They have SBOMs, provenance, and etc. This last particular slide is we want you to Chainguard your open source software stack. So at the bottom, the foundation of all of this is the Chainguard factory. On top of that is the Chainguard OS. We make and distribute our own operating system. This allows us to have that 7-day critical SLA, 14-day high, medium, and low for system packages because we're not at the mercy of a third-party distribution. Most importantly, this operating system is minimal, has a small footprint, and believe it or not, it was actually inspired by Alpine. We used to have mutual support and we got tired of being confused, so we dropped it a few years ago. After the Chainguard OS, the next product is Chainguard Virtual Machines. Chainguard Virtual Machines are the same as the hardened container images, except it's a VM effort for it. So instead of having an Nginx container, you could have an Nginx VM with Zero-CVEs. All of our images and VMs also come in compliance flavors as well. We have FIPS versions of a lot of our images, over 700 FIPS images, and those FIPS images can also be made into Chainguard VMs. We talked about Chainguard containers. You see tool chain, we protect the tool chain, runtime, and most importantly, we also have Helm charts. They're called Chainguard I am guarded charts. When Bitnami put their stuff behind a paywall, we decided to step up and make charts to serve the community. So we have roughly about 40 to 50 charts that you can use with Chainguard Helm charts. And then last but not least, Chainguard libraries. So Chainguard libraries is one of our newer, more exciting features of where instead of using PyPy, for example, for your Python packages, you would use Chainguard. Those packages will come with malware protection, provenance, and also CVE remediation. Currently, we have Python and Java available. JavaScript is in early access. And the goal of libraries is to try to secure every open source library that we can. Up on the roadmap will more than likely be Go and Rust, followed by a few others over the next couple of quarters. And again, the idea is to secure the entire stack. So one main thing I want to note on Chainguard libraries, one of the nice things about Chainguard libraries is that you still can use third-party library providers. We don't try to lock you into our libraries product, our container product, or VMs. They're all customizable. Another thing on libraries, especially with Python, y'all know Python got about 700,000 plus packages. We're trying to work towards some balance. We haven't gotten that far yet, but we got about 20 to 30,000. We're still growing. Java, we have over 50,000 packages. JavaScript, I can't tell y'all the numbers because y'all didn't sign an NDA. So that's the factory. Couple of key points. The packages are built from source. They really, really are hardened by default by expert humans. I promise we don't use AI for everything. They're updated and patched quickly. That's mostly automated. That's what helps us to build at scale. They're minimal container images built from packages. They're reproducible. They're secure and they're tested on real clusters. They're rebuilt consistently to pick up package updates. And most importantly, they deliver hot and fresh to your door like a pizza. The VM images are the exact same, and then the libraries are a bit different. They're built from a verified upstream source. They're malware scanned, and they also have CVE backporting. One distinct difference with libraries than our images and our container product is that we essentially backport about 3 years back. So with images and VMs, we're not trying to support 3-year-old versions. But from a packages perspective, we know that some dev houses are still using their favorite Java package from like 1995. So we want to have an ability for those customers to be able to migrate to a secure form of a package and kind of not leave them out in the dust. Thank y'all for coming to my talk. I appreciate y'all.